Hi, this is Team 21010 and our project is the Tonee Lift. Before we get into any details in our project, we'd like to introduce ourselves. My name is Faris Al-Dawaisi and I'm an industrial engineer in the team, as well as the team lead.
My name is Ben Callahan. I'm a mechanical engineer and I'm also the procurement lead.
My name is Colin Lewis and I'm a mechanical engineering major.
My name is Zara Hassan and I'm an industrial engineer in the team.
Hello, my name is Samson Weisbrod and I'm the electrical and computer engineering major on the team.
Hi, my name is Petra G and I am another mechanical engineer on the team. The Tonee Lift is a walker featuring a vertical platform type plate that can lift various objects from the ground while the user is standing. This walker offers users with balance or bending mobility issues an alternative to commercially available picker or grabber devices that are often difficult to use or unable to lift heavier objects. According to Georgetown University, 8% of all adults experience persistent or chronic back pain which limits their everyday activities. Additionally, the CDC reports that 24 million adults in the United States are limited in their activities due to arthritis. Pain and stiffness in the hip, knee, ankle, and back can greatly limit people's abilities to kneel, bend, or stoop. A lot of this pain and stiffness can be caused by the aforementioned chronic back pain or arthritis. Additionally, as people age, the prevalence of stability issues or imbalance increases. LIO found that 14% of people 65 to 69 experience imbalance, 35% of people 70 and older, and 46% of people older than 85 have these issues. The Tonee Lift offers a solution to these problems and will hopefully allow people to go about their day with greater ease and achieve more independence.
A working prototype of this device had already been built before the beginning of the project, but the inventor and the sponsor of this project wanted to have this prototype further refined by improving its foldability and portability, the functionality of its lifting plate, its battery life, and its usability and controls. The prototype that the team was given had a drill motor as its control panel to control the motion of the lift, which made it hard for the user to control the motion and the direction. Additionally, the walker was only able to fold when the plate was in certain positions. The plate and the track were mounted onto the middle of the walker, which impedes the movement of the user when using the walker. Also, the lack of lots of support on the plate made it such that the plate would wobble and tilt when heavy objects were placed on it. The lack of sides on the plate also made it possible that objects could slide or roll off the edges of the plate. Finally, the lack of wheels on the legs of the walker made it harder for the user to move the walker.
The current prototype includes a rocker switch to move the plate upward, downward, off, and a button for emergency shutoff. Another thing the team had to improve is its lifting capacity. Currently, the system is capable of lifting 28 pounds, but it is limited to 20 pounds for safety reasons. In addition, the current prototype has a battery that is capable of providing enough power output for the system to function, and each battery charge shall last for 24 uses. The walker frame has wheels integrated on all 4 legs to allow the user ease of movement. We have also integrated brakes into the design to allow safer use of the walker. The lift housings are now mounted on the sides of the walker so as to be out of the way for the user. The rod across the 2 housings connects the plate and offers greater stability to the plate. The plate now features sides to combat the chances of objects falling off and a lip on the front so objects can easily slide onto the plate.
The newest prototype is designed to meet several key requirements. That it lifts 28 pounds. Will lift objects to the user's waist height from the ground. The lift will automatically stop when the top or bottom height is reached. The walker will be easily foldable. The battery will meet the energy requirement of a typical full day of operation. The walker will be usable in typical indoor environment, and it will have telescoping handles that can be adjusted to the user height.
The
The walker is composed of aluminum 6061 tubing and machined parts, as well as various ABS 3D printed plastic parts. This was done to keep both the cost and weight of the walker low. The low cost and accessibility of 3D printing allowed for the product to feature bigger, custom-made parts, like the lift housing and electronic housing. Otherwise, the parts would have cost too much or added too much weight to the walker. The two lift housings are mounted on opposite sides of the walker. This was done to keep the track more out of the user's way, have a more streamlined look, and keep the housing more stable. The two sides of the lift housing are connected by one drive shaft, housed within a larger hollow rod. The drive shaft is driven by the motor on one side of the lift housing, and pulleys move both sides of the lift in unison. The belts located within both lift housings connect to a sliding track, which in turn connects to a lift plate. The common drive shaft is important to ensure that the plate remains horizontal during operation. Locking brakes located on telescopic handles allow for the walker to remain locked in place during operation, and two joints located on either side of the walker allow for easy folding and storage.
The software was written in the Arduino IDE and integrated the system inputs to determine the speed and motion outputted to the motor, which is controlled by our motor driver. The Arduino Uno was chosen based on ease of use, lots of documentation on the microcontroller, and easy off-the-shelf accessibility. Our L298N motor driver was chosen for similar reasons, as well as the ability to control two motors in case of a dual motor design was to be implemented. The sensors were chosen based on their size and simplicity of it being activated using a magnet that moves with the lift. The DeWalt battery is bigger than our original portable battery, but was chosen with ease of removal and requirement of all-day use in mind. Our controls are a simple on-off-on rocker switch and a push button for an emergency stop feature. Both were chosen to keep user interaction as simple as possible while achieving our lift requirements.
Of the $4,000 allocated to the team for this project, we have currently used $2,522.94. This leaves the team with a remaining balance of $1,477. The anticipated manufacturing cost of a Tonee Lift walker is $853.93. The team believes that by utilizing mass manufacturing, the price will drop dramatically. With that in mind, the consumer price will range from $1,000 to $1,500, keeping it in the range of some of the top walkers on the market.
We'd like to thank our sponsor Gabby Doyle for trusting us with this amazing project and for helping us, as well as our mentor Steve Larimore for all his guidance and advice. We are so excited to see where the Tonee Lift goes and the life that it changes.